So, I'm having difficulty here finding the moment. The moment.
Okay.
Yeah.
Abs.
Of this problem, I've already done the part of solving for the resultant force and then the angle, which are correct.
Good job.
And then, but I can't remember how to exactly get the moment or exactly, I know we're gonna have to add them together, but I can't remember exactly what I'm supposed to do.
Okay. So first of all, like you know, a moment is just a torque.
Mm-hmm. Not quite.
Not quite. It has the exact same formula
Yeah.
and the same meaning and same units. And
It's a moment. No, just kidding. I don't care. Just don't say torque.
Torque is moment. Is leverage is moments. Okay. So what you got?
This, 4109.
Okay. Are they couple moments? No, they're not.
Mm-mm. So it can't be easy.
It can't be easy. So there's a little force here. There's a force going down.
I thought you didn't do tutoring on Wednesdays anymore.
I
Dropped across.
It's at night that I have lacrosse.
Okay.
So I can't do tutoring after 5.
Because that was my panic just before you arrived. I was just like, wait, he said he wasn't doing it on Wednesday, but it showed up on mine still. I'm like, no!
Yeah, I can do it during the day.
Yeah.
I just can't do it. What number is this one? What is this?
109.
Force. Is it 3,
Oh, the force, it's a 3, 4, 5 triangle. 3 is on the opposite. So 3 is the height.
5 and a 250?
Yep.
And how much is this one?
500. Sine of 30.
30.
Mm-hmm.
30 degrees.
The one on the bottom is 300.
Okay. So and we are looking for the resultant forces here and the couple moment. Right?
Mm-hmm. Okay. I don't know which way it's turning.
It
It says counterclockwise.
just always, when you draw it on your Freebody diagram, always draw it in a positive direction. That's one of the things that is really key. When you have resultant forces,
So always do it counterclockwise?
always counterclockwise and make these always positive. Make the y in the positive and the x in the positive.
Okay, I don't quite fully understand yet, but let's continue, and maybe I will.
So it wants us to find the reaction forces. And so what a reaction force is a force that balances everything out. Because if you look up top, right here, these forces aren't going to balance each other out. They're not going to be in equilibrium.
Nope.
But since the whole system is in equilibrium, there has to be another force to balance it out. And that's where this comes into play. So if you were to add all of these together, you'll get a resultant force, right?
Which I've done.
And that will be your reaction force, because it just has to oppose
Okay.
the other forces. And so that's what it is, it's just a force that's opposing. It's like if you have a pole cemented into the ground, and if you were to pull one way, it's going to resist, and if you pull another way, it's going to resist, and if you try to bend it, it's going to resist as well. So what did you do here?
We don't need to write all that out. Let's just skip it and say the force is 542.
So the force in
The
the
force
x?
resultant is 542.
Okay. What was the force in the x?
It was negative 533.
533. Okay. And force in the y?
100. Yes.
And on your free body diagram, did you draw the arrows like this?
I didn't draw any of those base arrows.
How did you use your AX, AY?
I didn't. That's why I'm saying this is new.
Oh.
Well, I didn't say that. I'm like, I didn't know about this turning and...
So basically what we do to find these,
I know how we found them.
what do we need to give to...
Look at my
What would
words.
this be called? It would be called moments.
Of Jeff.
Reaction forces 1138. Cool. So what we do is we have to draw our free body diagram first. A free body diagram is basically a drawing that has all of your forces on it. If you don't have it right, you're gonna get it wrong in the end, most likely.
I know you're explaining for the camera.
I
know
right?
this.
So
Got
you have to draw these though. If you don't draw them,
Well, what are they?
so what these are, they're forces that you don't know the value to.
So we don't know the turning direction, and I don't know where you have this AX.
So there's an AX, AY, and the moment about Z. It's like if you were to put a pole in the ground, right? And if you were to push that way, the ground is going to push back that way. In this case, that'll be AX, your AX. If you try to pull the thing out of the ground, it's going to resist it. And if you try and bend it, there's going to be a moment that's going to be opposing it. And so that's what these are. They're reactions to the forces. But we still need to find them because otherwise the system will not be in equilibrium. And so to find them, you do the sum of the forces in the X, kind of like what you did. Sum of the forces in the Y, and the sum of the moments about a point. You'll have 3 equations and 3 unknowns always. Almost always. And if you have the 3 equations and you have 3 unknowns, then you can solve for a bunch of stuff. So what you did is you broke up each force into its X and Y. Can I see what you did? So you did the... I'll just do the sum of the forces in the X real quick. And then we have to put this in here as well. So it's going to be a plus AX, and that is equal to 0. Then if you solve for AX, you get your AX is equal to negative 533.
Okay.
And so what that means is that you just, the negative sign indicates that you drew your arrow in the wrong direction on your free body diagram at the very beginning. So really the force is pointing this way. At a magnitude of 533 degrees.
I know that.
Why
It's negative.
Yeah, I know.
I know.
I'm just showing that's
That's
what
how
these
it's
are.
supposed to be.
That's
It's always supposed to be positive.
Yeah.
Okay.
And that's what these are, the reaction forces, and you need to find them. So in
Okay.
your formulas, you have to have your reaction forces as well. What are we solving for? Because you solve for...
I've already solved for
that.
first resultant. I've already found the angle.
You
I
found the
need
moment?
to find the moment. That's the thing I don't know how to do.
Perfect. So we have our...
I think I have 5 seconds.